Welcome to CESTiCC's webinar series, Sustainable Winter Road Maintenance Operations. Tina Greenfield is presenting the fourth webinar in this series, Performance Measures for Sustainable Winter Road Operations. Questions should be held to the end, and then I will unmute everyone so there is opportunity to ask your question. And with that, I'm going to turn it over to Tina.
All right. Well, thanks, everybody. Thanks for the webinar team for inviting me to present. And thanks, everybody, for attending this webinar. Hopefully, we'll have a lot of fun here while we're discussing what may be a kind of an intimidating topic. But there's a lot of cool things going on that I want to share with you. And in specific, well, mouse going there, here's our outline. So for the next 15 minutes or so, I would like to talk about, first of all, why we bother to measure in this winter operations world, some types of measures and how to choose what might work for your agency. We are going to then talk about how to use that data to make decisions and how to present that data so that the people that you're giving it to understands it and knows what to do because of it. And really what we're going to do through the bulk of this, presentation is focus on some practical applications and step through the process start to finish so you can see how all the parts and pieces work. And hopefully by the end of this, you'll have a framework that you can take back to your agency or wherever you work and apply that to whatever data that might be available at hand for you to do some useful performance measurement. So with that, I'm going to step right in. So first topic, as I mentioned before, is why measure? And for some people, the answer is because you have to. And we're not too worried about checking the box with this webinar. We're going to focus on how measurement can help you. Winter maintenance is really complex. You have different weather systems that are never the same. One storm can come in and it behaves like this, and you've got another storm that comes in and it behaves differently. You've got different regions experiencing different weather scenarios and different expectations for the types of roads they take care of. It's also very costly. Just for an example, here at Iowa DOT, we budget somewhere between $40 and $60 million on winter maintenance operations on our state and federal highways. So a little bit of benefit can turn into a lot of real money when you're talking about that many zeros in the budget. And then it's also constantly changing. We have elected officials who make our policies and help drive some of our greater goals, but then we also have new blades, new equipment, new de-icing materials that are coming on the market, new technologies that we can pick up. And winter administrators like me, we got to kind of keep track of what we're doing and whether we're making sure, whether our standards are being met, look for those new opportunities with that new equipment or that new material, and evaluate how things go and move forward in the most effective way possible. So some of the questions that can be answered through some kind of measurement guided improvement is, for example, a few of these things. You've got a de-icer that comes on the market. It's expensive, but does it lead to a quicker cleanup time? Did this new process do what it was promised to and lead to better results? Can we do the same or have the same outcome but not spend as much money, like if we're in a budget cut or something like that? Generally, are we moving where we need to go? Are we moving forward? Are we improving? And can we communicate a need back to our budget folks or the powers that be if something isn't going the way that we would like it to? Can we justify that with them in a way that they would understand it? So that sounds great. Performance measurement, though, requires a little bit of diligence. So I'm going to go through and first talk about some of the types of measurements and just introduce you to some of the different measurements that are in use today, and then also what might work for your agency. So I kind of basically separate the different types of data that I use for performance analysis into 4 different bins. I have inputs, outputs, outcomes, and normalization factors, which I will sometimes also refer to in the course of this presentation as external inputs. And I'm going to kind of discuss these in turn, and I'll introduce each one and then some examples of different types of inputs that might be available for you. So the first one that I'm going to talk about is inputs. Inputs are the things that they're basically the resources that you used in order to do something. They really help describe the expense of the operation or the cost expenditure. They also tend to be the simplest thing for most people to deal with because they are often collected already as part of your resource management system, your budgeting, your payroll, and things like that. So some inputs that might be readily available to you are things such as tons of de-icing material used and its type, tons of sand or grit, gallons of liquid de-icer and the type, how many labor hours you used, equipment hours, how many plow blades you burned through. All these types of things can be considered, really good inputs to use. So really, when you're selecting these inputs, oftentimes you can and should start with what you've got, because you probably have some of these laying around. Of course, the more granular you can get them, or the more specific you can get them, costs by location or costs by route even, are going to help you become a lot more specific with your investigations. But a lot of people at least have expenditures of certain, labor, equipment, materials, broad categories. And so if that's what you've got, go ahead and start with it. And if possible, study several inputs, because sometimes, going back to this winter maintenance as a complex beast, sometimes maintenance activities can shift costs from one type of a category to another. And so you gotta, when you're looking at inputs, you kind of have to keep a global view of what all is going on. So for example, I have up here that, some materials might be very cheap to use, but lead to higher labor costs. Or sometimes those nice blades that you can get are expensive. So your blade costs may go up, but they might lead to a reduction somewhere else. And so it's good for you to kind of be specific with what impacts what, but keep in mind that there is a total picture, this whole total winter maintenance picture, which you have to keep in mind when you're looking at your inputs. And so, for example, your study of inputs will help your agency select the most cost-effective balance of whatever you're using in order to do your work out there. Outputs are going to be the types of things that you do. These are the tasks that were accomplished in the operation. So they describe processes, activities of different philosophies even about how different places might tackle the winter maintenance problem. And these are things that will help you investigate what are the good processes and what are the bad processes, or maybe bad's the hard word, maybe the less effective processes. And so some outputs are things such as miles plowed. And it's also really good to say miles plowed by what? Well, which type of blade? Miles plowed by blade type 1 versus blade type 2, or by truck type, or whether or not you use down pressure, or whether you use a plow balancer that actually lifts some of your plow pressure up. Plowing width or plowing speed, whether or not you use a wing. So even just miles plowed has a lot of different things, a lot of different different ways that you can think of miles plowed even within that one category. You can also do the same thing with miles treated. Well, treated how? By which chemical and what rate? You can talk about maybe the timing of how they do their treatment. So whether people do anti-icing operations or whether people in your agency tend to do a very frequent treatment versus a hit it hard and then leave it for a while kind of a maintenance philosophy. Use of pre-wet. You can look at various spreader systems for how you place the salt down the road, whether you use zero velocity or some other plate spinner. There's a lot of different things that people do when they're doing winter maintenance, and these outputs are a description of those things. So when you're selecting your outputs, and this is going to be a theme. You'll see this just about on every single slide. Start with what you've got. These are going to be a little bit more tricky because they might require special data collection or an investigation or some information that will allow you to know who uses plow blade A versus plow blade B, for example. So you can do surveys, you can maybe get some information off your GPS AVL, you can simply talk to different maintenance managers and get an idea for who does what. But because you kind of have to dig in a little bit on that, these are slightly more challenging to collect than your inputs. And the outputs should also be specific to the activity that you want to improve. So getting them as specific as you can kind of helps, because it really helps you hone into what was the difference that really did the trick. So miles anti-iced is more description than miles treated, because you're getting down to, did they anti-ice or did they not? And if there is a difference between the people who had anti-iced and not, then you can be relatively certain that the anti-icing part of that equation is what made the difference. Whereas miles treated, kind of as a blanket statement, might make it really hard for you to kind of pinpoint what it really was that led to the change, led to the difference. Of course, if all you got is mild treated, use it. And then, as I mentioned on the previous slide, it's also handy to define a control and an experimental side. So you're comparing two different blades. You got blade A, you got blade B. You've got method, the traditional method versus the new method. You've got the material you've been using for years and years and years versus the new material that you just got a hold of. So something that you can kind of compare before and after, or experimental versus control. And then the next category is your outcomes. These are the ones, the ones previously were outputs. These are outcomes. These are the actual result. They measure the effectiveness of your operation and have a direct impact on the customer. Honestly, the customer usually doesn't care whether you're anti-icing or not. They just want to be able to travel safely. Were they able to do it? Did they have to slow down? How much did they have to slow down? How long did they have to wait for a road to return to the bare or wet condition? Things like that impact them, that actually change the driving conditions or the risk that they're taking trying to drive on the road. And these tend to be the hardest to quantify, because you need to collect that information and do it reasonably objectively and repeatably. And so in selecting your outcomes, there can be a lot of discussion about what is the best measure. And I would say that the best measure is the one that actually gets used. So again, do what you can, start somewhere. There are some very simple measurements, or very straightforward measurements. The first one I'm going to talk about here is a visual indication of road condition. In some form or another, this is a very common performance or an outcome measurement. Things such as, what was the road surface? Well, is it dry? Is it completely covered? Is it partially covered? What's it covered with? You might have condition that says, okay, it's snow or ice. You might just have a road condition that says, is it normal or not? Here in Iowa, we have a visual indication of road condition that we have to record, and it's time to normal or time to wheel path. You know, how long does it take to get at least one bare wheel, even if the rest of the lane is covered? And so there's a benefit in using these in that they're pretty easy to comprehend. If you try to describe this road condition outcome to anybody, they would understand. It's like, all right, how long did it take for the roads to return to normal? That's something that most people can get. You can also use the different categories from dry to partially covered to snow covered to, you know, impassable is kind of some sort of scale that will allow you to assess, you know, not just whether it was normal or not normal. You can get into, well, it was only a little bad or it was really bad, and try to maybe sort of sort out some kind of a scale of impact. You can use just the amount of time that it took to regain as its measurement, not exactly the state. But the downside is that in the end, you are looking at a visual indication that somebody gave a road segment. So that's often self-reported. That's often the plow drivers or the supervisors themselves who are reporting that. It's also the case that if you asked two different people what the road condition is, you may very well get two different answers. So it's easy to comprehend, but sometimes there's a little bit of wiggle in this one, just because by its very nature of being someone's judgment, there is some amount of subjectivity just baked into using this one. But it's very accessible and something that a lot of people through their policies have to collect anyway. So again, it's a decent place to start. Another one that might be interesting for you to consider is traffic speed. Now, this one relies on the assumption that traffic will respond in a certain way to a condition. And so if the weather is bad, it assumes that the traffic will slow down and will speed up as the conditions improve. And that how much they slow down or how long it takes for them to regain are also indications of kind of a relative rank as far as good going down all the way to very poor. So in traffic speed, you can study the regain time, you know, how long it takes for that speed to return to normal. You can study hours of non-normal speeds throughout the storm. You can study the magnitude of that speed reduction. And so there's a lot of different things that you can do with it because it is a continual variable a lot of times when you get traffic speed. But it does require a sensor system or that you have access to a reliable traffic data subscription that is populated enough that it works in all hours and even during storms when a lot of times, at least around here, sometimes people actually stay home. And so if you do use a traffic data subscription, you have to make sure that it's robust enough for the roads that you're applying it on are busy enough that you have enough of a traffic sample to continue receiving good information. It is continual, as I mentioned before, so you can study impacts throughout the course of a storm, not just at the end of the storm and you know, like the time to normal stuff that we discussed on the previous slide. You know, this is something that you can actually get some good information as the storm develops. And it isn't subjective. Most of the time, your traffic speed sensors are going to read the same thing, whether or not it's snowing, with some exception. But in general, it does kind of remove a little bit of that human element. The problem with it is that it can also be influenced by other factors outside of your control, so you have to be a little careful that you're not picking up on things such as a special event just got out, a ball game just released, and everybody's on the road and the road's really congested and people are slowing down because of that. not as much so the winter weather, or to what extent is it one versus the other. So there are things that you kind of have to be a little careful with when you're using traffic speed, but otherwise can be a fairly sophisticated measurement system if you have access to this kind of data. The final one that I'm going to give you an example of is road friction. And this one, like traffic speed, is highly related to the ultimate goal of your winter operations, because it literally says, road is slippery or not, or how slippery is it. And so it's highly related to how well you're doing, and it's a continual measurement oftentimes, not subjective. But again, problem being that you have to find your own friction sensing system. You have to mount them to your patrol vehicles, or you have to get friction sensors for your RWIS sites or something like that, so that you can collect this information, because there's really little other source for getting this kind of data. So it's great data if you can get it, but you have to go through your own expense of finding it. I can't even think of anybody who can get this through a subscription service even. It's something that an agency would have to supply themselves. So great information, but some access barriers. So really quick, I just wanted to go back and say, okay, we talked about inputs, outputs, and outcomes a little bit. Just some quick examples of where we can find some of this information. And ideally, your agency should seek your inputs, or outputs, I should say, that maximize your customer satisfaction outcomes while reducing the inputs. Doing more with less, basically. So, to review, you can say that a certain amount of an input, say salt, can be used in various ways, which is described by your outputs. And that can have some kind of a difference in what actually is occurring on the road through your output. The next one is a little weird. This is your normalization factors, and this is sometimes the one that I mentioned that I call the external inputs. Using inputs, outputs, outcomes to say, okay, does doing this thing lead to lower costs while not sacrificing level of service is a pretty simple question to ask. And a lot of people have enough, they've had enough experience in science class and other places that they know how to put an experiment together, and they can kind of get that figured out. However, because of the complexity of winter maintenance, we need these normalization factors. And I think the best way that I can describe that is through a really quick example. So I showed the slide earlier. There's some of the neat things you can do with performance measurement. Set up all of your expectations to performance measurement's going to show you all kinds of things. But there's always the buts. If you tried de-icer A and you compared it to somewhere else or some other time that you were using de-icer B, the old versus the new, and you said, yay, our cleanup times are down. But did we just get an easy winter this winter versus last year? Or if one location does something and their costs are always lower, well, or do they just have fewer miles to maintain? Did they get a different winter than the location Y? So all these little yeah buts kind of start creeping in. And it's where these external inputs, basically, things like the weather, the things like their workload, these are important because they really obscure the effectiveness of what is really going on if they're not removed. So what are these things? These are basically the complexities. You got to consider them, you got to measure them. And by their definition, they're more or less outside of the control of the agency or your maintenance team. So weather is one of the big external inputs, so to speak. You know, you can have a storm that hits one region, doesn't hit another region. You can have one storm season, one winter that's very, very severe. You can have another one that's not. So naturally, if you have different weather conditions, people are going to be using different techniques because different storms require different techniques. They're going to be using a different amount of resources just because of the way the weather hit them. So for the weather normalization, you'll be using some kind of weather index. The other thing that is really important to think of is the level of service of one location versus another. So here in Iowa, we have 101 maintenance garages, and each maintenance garage has a different combination of types of miles and how many of each they have. So we have, you know, our policy dictates that we treat our interstates different from other types of roads. And so if you have a mile of interstate, you're probably going to be, your workload on that interstate is going to be greater just by the fact that it's an interstate and it carries a lot of people on it. And so it's kind of like it's your workload, and you can't help that interstate is busy and people rely on it. But you have to, a maintenance supervisor would have to respond to that, and they can't just choose, well, I'm going to treat it as a level B, where I guess they can. But there are some expectations that go with those types of roads. So that's where a mile index really comes in handy, particularly if you are going to be comparing one location to another. So some simple weather normalizers are inches of snow. I know it's pretty easy. A lot of people can wrap their head around that one. Storm hours, or maybe even number of storm. Nice thing about these is that you can measure these with your own eyes to a certain extent. You can simply count how many storms hit your area or various areas. You can go and look up weather data and look up inches of snow, and how, you know, if you have a weather station around, you can look up how long it was snowing. So these types of things are pretty easy to get your head around. The weather indices, or a weather index, is not quite as intuitive. However, they combine multiple weather characteristics into one score so that they can more completely describe the influence of weather than the single variable normalizers above. So inches of snow up there, that sounds pretty intuitive, but the problem is that if you're from Iowa and you also get freezing rain's a big deal, but it wouldn't count at all in your inches of snow. So having a weather index that can take into account, oh yeah, and oh, by the way, there was some freezing rain too, can help lead to a much more sensitive normalization factor that really is a little bit more in tune with the true difficulty of the weather that was dealt. Well, the more complicated they get, the better they become sometimes, but if you have to explain that to somebody, as I sometimes have to, it can be a little challenging if you don't have a few pictures and maybe a couple formulas that people can look at. And sometimes its complexity can be a challenge for its use. So weather indices and other indices can be created on your own. I have a couple of homemade indexes that I use here in Iowa. You can also swipe one from a published source. And really what it comes down to is the one you choose is often defined by what kind of weather data you have. So I have a couple examples here. This Cohen Index just basically has snow days and cold days. That's pretty easy. You can count those up, create your index. If that's all you've got, this will be a great one for you. This one down here with McCullough they have 7 weather factors that goes into this formula. They have freezing rain days, frost days, how many days of drifting snow, average temperature, storm hours, blah, blah, blah. And this is a very nice index. However, you have to have access to all 7 of those weather variables for the different locations that you are studying. So again, there's a little bit of a trade-off that sometimes greater sensitivity comes at the cost of having to find all that data and smoosh it into an index. If you happen to create your own index, I just want to spend a little caveat here. When you're talking about a normalization factor of any kind, what shouldn't appear in that index are things that you have control over. So I have seen a number of places where a weather index has salt use in it, which is a little bit of a pet peeve of mine, because although, you know, it makes a little bit of sense because you might think, oh, well, salt use is correlated with weather. You know, the more winter storms we have, the more salt we'll use, and it's easy to measure salt, so we'll toss our salt use into the weather index. The problem is that salt use is a decision that's made by the agency. And so if you have one region that uses a lot of salt and another region that really doesn't use a whole lot of salt, they use a different chemical, their weather indexes are going to be different because of the way they chose to fight the storm. And so if you're trying to get down to the bottom of whether that choice is effective or not, if you bake that into your index, you will not be able to separate them. So factors that rely on weather and agency decisions can't be used to separate weather from agency decisions. It's important that any of your normalization factors are more or less out of the hands of any of the people making the decisions during the winter storms. So I've spent the last half hour kind of introducing the basic tools for decision analysis. And so what I'm going to do now is I'm going to go through an example for how you actually put all those together to come up with some interesting findings. And I'm going to do that through the course of a little example. And so it fits on pages and can be legible. I have an example here of 10, an agency with 10 maintenance depots. And in this example, each depot tends to use different practices. And you want to know, is their practice of pre-wetting, that some of them do and some of them don't, linked to better outcomes? Or is perhaps pre-wetting linked to a better cost outcome? And of course, through this example, each depot is going to be responsible for a slightly different set of roads and is going to be impacted by slightly different weather patterns. So as I step through this example, I'm going to kind of go through these 8 steps. And I'm going to describe each one as I go, but just as a little summary, I'm going to first identify the data that I have as far as the inputs and outputs. And then I'm going to create some weather and lane mile indices. I'm going to kind of put everything together and compute and organize the data and kind of just take a look at it and see if anything pops out at me. I'm going to apply my normalization factors as far as, what's our cost per mile per unit severity. And then I'm going to start correlating things. I'm going to apply a correlation. Is the use of pre-wet at all linked to a lower cost outcome? Do they step together, or is it no pattern? And then I'm going to take a look at the outcome. And I'm going to say, as number 6 looks at cost, I'm going to look at outcome in number 7 and say, did the lower cost or a cost change or just the practice change, did any of that come at the expense of the final outcome? And then finally, the continuing evaluation step. So I'm going to kind of bunch steps 1 through 3 here. I'm going to take a look at what we've got. So we've got depots A through I. I kind of chopped this chart off a little bit so you can read the numbers a bit better. But in column 1, we have an input. basically a total material cost. We have an output, which is a description of how they pre-wet and what their typical rate is. And we've got some zeros in there, we have some 5s, 10s, and then later when we get into the table, you'll see 20s and other values. You can see an indication of their outcome as far as their hours to normal after the end of the storm, some components for a mile index, and some components for a weather index. So we actually have some pretty simple data here, but we have enough to do what we need to do a thorough evaluation of whether pre-wet rate impacts cost at all or impacts time to normal. So kind of the first thing we need to do is look at our weather index. We have two variables. In this chart up here, we had total snow hours and total freezing rain or sleet hours. That's it. They don't fit a published index, but we can totally make our own as long as it makes sense. And this index here is one that I mocked up for the purpose of this little example. As far as I know, it comes up to something pretty close, but biggest point with all this is that even if you have just two variables and you can't find anything out there that's in the published work that fits it, you can still spend a little bit of time and come up with an index that'll make sense to you that you can use. So I'm just going to apply this formula to all the information. And then I'm going to do the same with the traffic information. We had miles of A roads, B roads, and C roads in the table. In order to come up with this formulation, you really have to look at how your own agencies and goals relate to those different levels of road. For example, for a while here at Iowa DOT, this was the kind of the different balance that we used. Now, that's just the way we run it, but it's really up to your management to decide how the balance of effort or budget should really lie as far as your expectations. But this index creates a concept of a weighted mile. It says that one average or one weighted mile would be halfway between the A and B level of effort. And it also sets the relative difference. So if you look at the formula there, I've got a multiplier of 1.1 times A and a multiplier of 0.7 times C. And so that tells you that your A road is going to receive almost 50% more attention than your C road, or is expected to receive that much attention. So if we apply those formulas to the table that we had before, we get something a little bit like this. And it's all basically organized and we're ready to step in. Now, at this point, I want to kind of show you first how not to do it. And what I see a lot of folks do is they'll look at the material cost and they'll look at the pre-wet rate and they'll say, oh, if I correlated my pre-wet rate, which is my output, to my input, that should give me an idea as to whether, okay, you know, if I use more pre-wet, do my costs go down? And you can do that through the correlation. The problem is that when you do that calculation, you might get a pretty interesting result. This correlation, which would be if I plunk that in the spreadsheet and in my Excel tabulation, I would come out to a correlation of 0.49, positive 0.49, which would actually say that there is a slight tendency that the more pre-wet that's used, the higher the cost. And if you're not careful, you might be mad to think that this technique that you've been trying to promote is leading to increased costs. But that's because you hadn't looked at your mile indexes or your weather index yet. Again, different weather, different expectation as far as the types of roads that these folks are taking care of. So what we need to do is, whoopsie, flipped one too many slides there. So what we need to do is create a normalized cost. And so this normalized cost is going to be basically your cost divided by miles, or your mile index divided by weather. So it's cost per mile per weather factor. And this would, by dividing those, remove those impacts. So the more or the higher you score on the weather index, the more that cost is going to go down in relation, because the weather score is in the denominator. And same with the miles. So this is the column that we need to use when we're looking at costs, because it has removed the impacts of weather and those other external factors from it. So before we do that, kind of an interesting thing has happened. So I've circled a couple of boxes. 24.2 is the kind of the new normalized cost for Depot D, and Depot H has a normalized cost of 38.4. If you look over in the kind of the second column where it's just talking about their total material cost, just straight up not normalized, they're actually very similar, D being above H. But when you apply those normalization factors, an interesting thing happens here in that you actually see that Depot D is our new lowest spender when you consider their miles and the weather they have to take care of, even though they were pretty much average in the raw cost. And likewise, or contrary-wise, I should say, Depot H has now taken the crown for the highest cost miles and weather considered, even though it was pretty middling when you just look at the total, you know, basically the raw costs. So this is where you start to see some pretty interesting patterns kind of come out. If you were to do a correlation between your pre-wet rate and your normalized cost, you would get a correlation entirely in the opposite direction than before. Our correlation now is negative 0.66, which would indicate that the more pre-wet that they use, the lower their normalized cost. And so that is totally the opposite finding that you would have found if you didn't consider your miles and your weather, but is probably a little closer to truth. Because again, if you look at people's weather here, there's actually a great range. And again, you would expect if someone gets hit by bigger storms or more storms, their costs will naturally be higher regardless of what kind of technique they use. So this is a great finding. You can also take a look at it a different way. You can maybe split the garages or the depots in this example between those that pre-wet and those that don't. And you can compute averages for each of those two different sets. So you can say that the average normalized cost for the 0 pre-wet depots is $35.3 per weather index per mile index value. And the normalized cost for the ones that do use some kind of pre-wet is 27.5 or 22% less. So there's a way that you can kind of quantify this difference if you kind of split them out like that. So we have found, at least in this example, that pre-wetting does lead to a change, a positive change, a good change in total material costs. But step 7 is relating that to the outcome. So someone can be fantastically frugal with their salt, frugal in a nice way of putting it, and don't do anything out there and lead to great costs but terrible outcomes. But most of the time, just simply cutting costs is not what you want. You want to either maintain a certain level of service or maybe improve your level of service. So now comes in, well, was there any side effect? You know, their costs may have been lower, but did it come at the expense of a worse outcome? And so how you answer that question is you can compare the typical pre-wet rate to the outcome. And in this example here, the correlation is weak positive. It's basically close to no relationship at all, which is basically saying that in this example, at least, that the practice of pre-wetting and the accompanying lower cost that came with it neither helped nor hurt the time to normal. It pretty much just washed out. So in this example, there was a positive change on the budget side, a complete no difference on the outcome. And so you can kind of consider this example anyway to be a, kind of a success for budget stuff. Now, the next step 5, continuing evaluation, is, well, maybe you can keep going. Did labor costs compensate for the material cost? Did the folks that use the pre-wetting, did they have to expend more labor hours that would have balanced out the benefits they gained through the material costs? Or did they help save on that side too? Because that could be a double bonus. Was there any difference amongst the pre-wet rates? Was there any difference amongst the people that had 5 gallons per lane mile versus those that did 20? Was there a point at which the returns diminished? You can continue these kinds of looks and dig a little deeper and answer a few more questions about, what's working for you and what isn't. So the final topic, final couple minutes that I have here, I want to talk about how to present this information for easy understanding for the people that actually have to consume this data. And for this, a lot of it kind of hinges on level of detail and level of latency. The first thing I'm going to talk about is level of detail. And it really boils down to knowing who your audience is and what the purpose of this information might be to them. So detail can be good and can be bad. I'm a data analyst, and sometimes I have to be really careful presenting information that is too technical or too deep in the weeds, because people's eyes will glaze over and they won't get as much benefit out of it as if I just kind of kept it simple and to the point. So in my experience, the users of detail, the ones that really love to dive into the weeds with me, would be the local maintenance managers, other research people, winter administration folks, people who really need to know what it was about certain situations that they can make some kind of an operational difference. So it needs to be specific to their region, needs to be specific to their roads or their maintenance area. It has to relate to their choices. Otherwise, it's going to be just a little too vague for them to be able to do anything about. On the other hand, users of summaries are people like the public, upper management. Their interest is in general trends. Are things good or are things bad? They really need kind of a quick glance understanding. Generally, upper management doesn't have a whole lot of time to be micromanaging the pre-wetting choices that are made at a local level. They just want to make sure, are things good? And if things are good, great. They're going to be moving on to the next emergency of the day. If things aren't so good, then they just need to know that so they can delegate. Something needs to be done. Let's look into this and get the people who are involved and who are really, into the winter maintenance program, looking into something for them. And so short and simple explanations for folks who are probably not real versed in the winter weather world are going to be great for these types of people. Another thing to think about when you're presenting data is its latency, which is basically how long it takes for the result of your analysis to be presented to them, or to the people that will ultimately make some kind of a decision. And you have short latency and long latency and everything in between. but the benefit of short latency is that you can react. You get the result, it comes to you quick right after the event occurred. Your improvement can be very fast because you can start making improvements from the very first storms of the season. You also are very able to remember the details of what actually happened. So why it was that certain decisions were made. Were there any other factors that maybe weren't considered? What might have worked instead? You can, all those details are fresh in your mind because it just happened the other day, and you still remember that. The downside is that you really have to be, the data analyst, really have to be on top of things in order to get everything crunched out and presented for them in that short amount of time. It requires a sophisticated reporting system. It needs things to be coming in automatically, or it requires you to be right there, ready to go with your calculations as soon as the storm is done. The long latency stuff, you have more time to collect and you present your results, and you can do a lot more things by hand and spreadsheets and a lot of the normal stuff that people have around the office, email, you can send things out email and do a lot of calculation just with the normal tools that you have at hand. However, the longer you let something set, the longer it can be that a mistake will go uncorrected. So it could be that if something went wrong this storm and then it was a couple weeks before you got the results back, and meanwhile there was a couple other storms that came through, it's pretty likely that those same things that happened are going to happen in those intervening storms. And so it can take a long time for a mistake to go uncorrected, particularly if all of your metrics come out at the end of the year. It's springtime. Your metrics said that you didn't do so hot. Well, what are you going to do about it now? The storm's over. Your salt sheds are empty. There's not a whole lot that you can do except try to remember that for next season. And also, if you do have the benefit of getting that kind of information, even just kind of keeping that in the back of your mind can be a little troublesome because all the little details of what led up to that result get kind of fuzzy. You got a couple of storms that might have happened in the meantime, and you can't really remember which thing might have happened during which storm. And it just gets a lot harder for people to attribute a cause and effect. This is an example of a short latency system, automatic. It's linked to programs that run nightly. It's got the databases all hooked up to it. You can zoom in, you can select different dates and regions. A user can really drill in and get that specific information, and it's very timely. Problem is that this system has to be maintained, it had to be developed, it took a lot to go into it, and so there was a lot of things that had to happen behind the scenes for this to be possible. On the other hand, here's another system that we use at Iowa DOT, which is generic and done by hand. This is actually our public winter maintenance dashboard on our website. And you can scroll down, there's more information at the bottom that I didn't capture in the screenshot here, but basically we update this thing every 2 weeks based off of a spreadsheet. We computed it and post it by hand. So there's someone who creates that graphic, and there's someone who creates and updates that chart, and they literally do everything by hand and plop it up on the website. I mean, it's technology that every one of us probably has at our fingertips, but it is general. But again, this is the public information source. We're not too worried about being able to drill into incredible detail. We just want to make sure that things are running okay. So in a quick review, hopefully you've learned that measurement is really important for improvement. It can really help streamline getting to the bottom of what makes a good change or not. Components of your measurement program can be thought in terms of your inputs, your outputs, your outcomes, and your normalizers or external inputs. And that when you get all your information together, you have to be very careful to make sure you get your normalizers in there before you draw your conclusions. And then finally, after you get your conclusions drawn, that the presentation method that you choose to use is matched to who you are sending the information to, and that you are presenting it in a way that, you know, you've put yourself into their shoes and can think about how they're going to use the data to the best way that you can. So with that, that is my final slide. If you have any questions, I'd be glad to hear them now. Also, if you have any other questions offline, you can contact me. I've got my phone number and my email address here. So with that, if we have any time to field any questions, I'd be glad to take them.
All right, I'm going to go ahead and unmute everyone so that your muting is under your own personal control, and offer up this opportunity to ask questions. We have two that are that have been entered into the question bar. One is time to normal based on the end of the storm? If so, how do you define end of storm and who starts the clock?
Yes, fantastic question, and is perennially up to debate as far as time to normal. Well, what counts the end of the storm? So for us, the end of the storm is not when it stops snowing necessarily. The end of the storm is when it stops landing on the pavement. So for those who are familiar with Iowa, we're fairly flat. We got a lot of agricultural area that is kind of exposed, and the wind blows like crazy through here. It's very common for us to have blowing snow for days after the snow stops falling from the sky. So for our definition, we have we extend the end of storm to include as long as the snow is still depositing on the pavement, whether from the side or coming down from the sky. So how you define the end of the storm is going to be a little bit up to you, because there's also the trick of, well, you know, if the snow stops for a little bit and then it starts again, do you want to count that as one storm or two? So in time to normal, you have to draw that line. And I don't know of any universally accepted rule that says after X many hours, you count it as one event, or, you know, or two events versus one. But as long as you are consistent with that cutoff, then I think you can still have success with it. And in general, most, when I say time to normal, that is the case. You're right that it's time to normal after the end of storm. So hopefully I got that.
Okay, next question is, does Iowa DOT currently have an established system to analyze and do data visualization for wind maintenance?
We have a couple of different things going on. We have, so that webpage that I just showed a couple slides back is one of a couple performance measurement systems. It's the only one that is public facing. The one that was a couple slides back, if I just flip back to that. Okay, so this one's public facing. This one is our, I guess one of our official channels for communicating performance measurement. The one that gets used the most is related to this one here, which is internal facing only. It's called our SALT dashboard. It has a lot to do with our inputs and our outputs. However, the outcome side of the equation is nothing that I have that is repeatable, or not repeatable, is automatic. A lot of the performance stuff that I provide is still done by hand as per this. So we have a number of automated systems, but I would say as far as getting all the way to the outcome side of the equation, most of everything that we have is still fairly manual.
I have two more questions people have written into the question block. The next question is, how would you apply new winter maintenance technologies like heated pavement for your winter maintenance analysis?
So one of the ways that I could think about a heated pavement system might be in terms of operation cost. So I would expect that the system would take some kind of energy, like electricity or something to run the geothermal system, or to to generate, electrolyze those conductive pavements, or whatever your heated pavement system is. And so operation cost would be something that you can throw in there. And then also you could maybe even consider its life cycle. So an installation cost, for example, how long does it live? If it took, X million dollars to build, and it's expected to have a certain lifetime, that would be its cost to the agency in order to use that equipment. And so then I would treat it almost like any other input. So I would expect that there might be some times where your heated pavement cost is X, and you might have used a little bit of material cost Y on it, and you're probably still plowing it, and so you still have a little bit of labor cost. Your combined cost would be how you might compare it to the other places that maybe don't have a heated pavement system. So you may spend a lot less on material, you might spend a lot less on labor and equipment, but you spend more on, or you spend something for a heated pavement just to run it, whereas the other locations would just have the labor, equipment, and materials. So you would have to kind of look at the total package together when you are, say, assessing its outcomes and things like that. But I really think it's doable if you think of it in another term of just another input, another tool that people use to combat snow and ice on pavement, just like they would salt or plowing.
All right, the last question's a more general one. I think that is me asking about the future presentations in this series, and is there going to be a presentation on predicting the amount of material that will be needed for a winter storm event? There's 4 remaining webinars in this series. The one that comes closest to that subject is probably the next one in the series that will be happening on July 9th. No, that's not the next one, but the following one. The application guidelines for optimal de-icing and anti-icing may address that topic, at least in part. The other ones, the next webinar is Weather Services for Sustainable Winter Road Maintenance Operations. So I'm not sure if that one will address that particular topic or not.
I would be glad to address that question maybe offline, because this actually, the slide that you're looking at right now kind of does that, but just based on whether that has already occurred. But we did have some work on pulling that into forecast mode. So if whoever asked that question would like it, just maybe email me. We can talk about that later.
Okay. Any other questions that anybody would like to ask? All right, well, this concludes our webinar. Thank you all for attending, and join us next week for Weather Services for Sustainable Winter Road Maintenance Operations. That'll be presented by Chris Albrecht. on June 24th. Thank you very much.